Like Mr. Brooks said, my project is the design and development of a structural-based, eco-sensitive hydroelectric generator. Right now, we have a big problem. And that problem is fossil fuels. We are running out of them. It's becoming more expensive to harness them and to harvest them. So what we're starting to see is a big push towards renewable and alternative energy. I first got the idea for my project when I went to the Hoover Dam over the summer after 10th grade. And I was trying to figure out what I wanted to do for my project. And after I took a tour of it, I became fascinated with hydroelectric energy. And so I decided that's what I wanted to base my senior research project in. I wasn't quite sure what I wanted to do yet, but I knew I wanted it to be a consumer product. I wanted it to be something that somebody could, go to Walmart, pick up off the shelf, take out of the box, and start using. So I wanted to model my design after a practical application. So I started thinking about what's something small scale that everybody can use that would harness hydroelectric energy. And initially I started thinking about using the faucets and the showers, but that became a little too complicated with the pipes. So I started branching out saying, where else can I harness this energy? And a vivid image came to mind, especially because we're in Alabama, driving home one day, it's raining, what's new? And I look at the downspout and there's just water gushing out. And so because of that, it has that high velocity, meaning it has a high kinetic energy. And that gutter system that's on nearly everybody's house now, that creates a funnel and a focal point for me to be able to harness that kinetic energy. So I knew that's where I wanted to go. Now, the visual for my project starts by this. I can show you by this series of pictures. So I start out with rain. I'm harnessing the kinetic energy of rain as opposed to the kinetic energy of flowing water. That's why my project, it differs from all other types of hydroelectric energy so far that have been developed. So rain has potential energy when it's sitting in the clouds. When it falls, it has a velocity, and so then it has kinetic energy. If I'm wanting to do something like this, make it a practical application and make it hydroelectric energy, I gotta transfer it into electrical energy. So there's two steps I have to do. First, I have to transfer that to mechanical energy by using a water wheel. And then I have to transfer that into electrical energy by having it hooked up to a generator. And then finally, I gotta have some kind of circuitry so that I'll be able to charge what I've decided I wanted to do with this project is charge a cell phone. So I had to create some circuitry to be able to charge a cell phone and have some kind of temporary storage, which would turn out to be a lithium-ion battery. So first thing I had to do is I had to get a huge basis of knowledge. I mean, I didn't have to know it that well, but I had to learn what, voltage, current, circuit design, circuit analysis. I needed a basis of knowledge before I could really go on with this project, because before I started, I really had no knowledge of electrical or mechanical engineering. So that was the first thing I had to do. Next, I kind of already described to you my rough outline. You have the potential energy. You have it transferred into kinetic, then mechanical, electrical. You want to store it temporarily, and then you want to use it to charge cell phone. So one of the first parts I have in my design is a turbo wheel. It's a specific type of water wheel, and why I chose it is because of its specific paddle geometry, which makes it most ideal for the velocity that you'd be getting with the rain falling through the downspout. Next, once I chose that part, I had to deal with my generator, which gave me quite a bit of trouble. So when you think about generators or alternators, or what usually comes to mind is those big engines in your car or something like that. The only problem with that is that those run at about 7,000 RPMs. And if we're trying to think of logistically how fast my wheel is going to be able to be spinning by using rainfall, all you're going to get is about 60. And the big problem is that there's not really any generators or alternators out there that work under such low RPMs in the kind of conditions that I was trying to use. But I eventually found one that used a wide range and produced the correct amount of voltage. So what I had to do with it then is the connections didn't work. The shaft for the generator is pretty skinny, and the arbor that I have on my Pelton wheel, or my Turgo wheel, sorry, they don't connect together. So what I had to do is I had to get another arbor, to connect to the generator, grind down that arbor so that it would fit inside my larger arbor, and that's pretty much why I titled this Arbception. It's a reference to the movie Inception, an arbor within an arbor. So the next thing I chose the next thing I decided upon was my single-cell lithium-ion battery charger. Now that is really a crucial part in this design because that's what's going to charge my cell phone and my other rechargeable lithium-ion battery that I use later for temporary storage. So why I chose this is because it has a lot of interesting, at least to me, interesting features. It has two main ports that I was using, a battery port and a system port. And what those two are, the battery is going to be connected to my lithium-ion battery, which is my temporary storage. And then system is what you'd hook up your cell phone to. So I chose that because it would have the correct functions that I'd be needing, and it would have interesting ways of charging the lithium-ion batteries and the cell phones to optimize the energy I've harvested. I pressed back. Okay, so the battery is the next thing I chose. This wasn't too complicated to pick, but why I chose it is because it has a large charge and discharge cycle. And what that means is it can be charged and discharged over 500 times without having to replace it or before it starts becoming less useful. So really, the consumer wouldn't have to really mess with the batteries at all. Next, I had to do a step-up converter. Now, with that, when you have that single-cell lithium-ion battery, you have the BAT, which produces an output of 5 volts, and that's what you need to charge a single-cell lithium-ion battery. Well, that cell phone also has a single-cell lithium-ion battery, but the output for system is 4.3 volts, and so that's not sufficient. So what I needed to do is I needed to get something else, which is a step-up converter, which would step up that voltage from 4.3 to 5, and then I would have enough voltage to be able to charge the cell phone as well. This is probably one of the most complicated slides of my presentation. That's why it fills up the whole space. This is what's called the schematics. It shows what every single part that's going to exist in my circuitry and how they all interconnect. So I'll just go through very quickly because I'm not going to try and explain this all to you, and I'm already probably running late on time. So this is the first part of my circuitry. That is a Zener diode and a resistor. Now what that does is it regulates or limits how much voltage can go into my system. So for my single cell lithium-ion battery charger, it can handle 4.15 to 16 volts. Now like I said before with that generator, although I found it working under very low RPMs, it has a wide range, and so it can produce too high of a voltage, which would end up burning up my circuitry. So I had to limit that to 16 volts. The next part, this huge big section, all of that's my single cell lithium-ion battery charger and everything, all the components that go along with it. Next, here's what I just explained to you, the step-up converter. And then finally, at the end, I have a micro B port, which is now the standard for nearly all cell phones that are manufactured. Verizon, AT&T, they all use it, and so that's why I chose it, so anybody would be able to hook up their cell phone to it and charge their cell phone. So first I had to do initial testing. When I got the lithium-ion battery charger, I got what's called an eval kit, and it's short for an evaluation kit. And engineers use this when they're trying to decide if they want to include this part in their own design. And so they give you a board that's already pre-made with all different functionalities that you can test and see if this is what I want to use. So to save money and time for me, I just went ahead and used that board. So that would save me a lot of time on making my own circuit board and everything like that. So I had to test to make sure that worked first. That was the first test I went through. So I had to make sure the battery had it outputted 5 volts and then 4.3 volts. It worked under the operating voltage like it said it would, and throughout those tests, it was all good. So the next thing I had to do, which is probably one of the most major parts of my project, is I had to create the printed circuit board. And as we talked about before, the first thing up there is the schematics.